That was excellent. And Jack and Carlos, I wish I had your microphone because that was truly stellar. Everyone, welcome today, and welcome especially to Matt Ballio. Matt is our speaker. He is one of the global technical leaders for the AI strategy and governance offering at IBM Consulting, where he drives thought leadership and client enablement around the trustworthy design, deployment, and oversight of predictive, generative, and agentic AI systems. With over a decade of hands-on experience as a data scientist, data engineer, and architect across diverse industries, he prides himself on helping clients navigate all aspects of the AI lifecycle responsibly, bridging innovation with practical, sustainable outcomes tied to business value. Thank you, Matt, so much for being here today. The floor is yours. The microphone is yours.
Thank you so much, Gretchen. Happy to be here. And hello, everybody. I hope you're having a nice Thursday. You've almost made it to the weekend. So I just want to kind of double down on the intro here. The one thing I want to mention was that I'm on the AI strategy and governance team. The way we look at that is basically we help clients do the right AI. So knowing what cases to focus on, how it's tied to your business strategy and how to get the most value out of it, and how to do AI right. So that's where the governance aspect comes into play. And that's kind of where we're going to be sitting on the conversation today. So we're going to talk about agentic AI and how cybersecurity is important because we have a bunch of new risks we need to be aware of. We also need to figure out what those mitigation strategies are so that when we do want to maybe figure out why everyone says this thing is so cool and so promising, that we know how to do it and use it in the right way. So let me go ahead and share my screen and we can get into all the fun stuff I have for you today. All righty. So the fancy title for this is The Promise and Peril of Increased Autonomy, and we'll talk about what that means as we go through. Normally, when I do conversations like this, I tag team them with our global trustworthy AI leader, Phaedra Boinadir. She may have spoken at a call or a talk like this in the past. She's not able to join us. She's off in Greece doing something very similar with Pfizer and a couple other clients. But if you are so inclined, we have a video on YouTube that you can go check out on the topic that's very similar to what we're going to be hinting at today. So if you'd like, you can go get some more little tidbits from us over there. But I don't want to spend the next hour talking at you. I want to make sure that this is engaging and you guys can get something a little bit different out of this experience. So if you wouldn't mind grabbing your phones and scanning the QR code on the screen, we're going to use something called Menti to be our interactive partners today. And I promise there's no logins required. They don't need your email. It's just going to show this exact same thing on your screen on your phone. And I'll be able to see as you guys join. 13, 14, 15 of you are already in there. So I'll leave it up for a little bit longer to let us all kind of get acquainted inside the platform. And if at any time you didn't get the QR code available from this screen, you could just go to menti.com and on that page you'll be prompted to enter a code. That code will just be 31640162. So this should remain at the top of the presentation as well if people want to jump in at a later point in time. So we'll give it a few more seconds here and then we're going to jump in. So we've almost got 30 people. That's pretty good. Okie dokie. Let's go. So sanity check. This should now be the thing you see on your phone. And I always like to start with this type of question just to get to know the audience a little bit better and see where everybody's at. So what you should be able to do is type on the screen on your phone and say, what type of AI are you most familiar with? Salt, butter, pepper. I will say that is the first time we've had answers like that show up. I'm not exactly familiar with those types of AI, but we'll happen to see what goes on here. ChatGPT, Gen AI. Okay, a few more normal answers are starting to show up. Predictive, LLMs, Copilot, learning. Okay. We're starting to see a lot more of the common ones. So machine learning, predictive, generative, ChatGPT, Copilot. Okay, great. So, oh, even some transformer-based chatbots. Should be transformer-based LLMs. That's awesome. And even some stable diffusion. Okay, so we've got a good diverse mix, I would say, in this audience here. Now, to make things a little bit simpler for all of us here, and the intro may have spoiled this, we just kind of like to look at AI in three large buckets to simplify this process. So we've got predictive AI, we've got generative AI, and we've got agentic AI. So predictive AI is what some people may call kind of that traditional or old school AI. It's been around for a while now, and it usually helps you solve the problems of, can I classify a person as somebody who's going to churn, or am I trying to predict a number, like what's the total lifetime value for a potential customer? And we say that this type of AI kind of informs or guides you. And it takes as input some typically structured data or unstructured data that gets converted into structured data. It gets passed off to a model. These models are not large language models. They're different types. So think like a classification or a regression or a time series model, if those words mean to some people I saw from the last slide. And your outputs are like I mentioned. You get a classification, you get a number, you get segmentation, you get some sort of output here. And this type of AI was what dominated everything until about the end of 2022, when AI had their Chat GPT moment. And enter generative AI. We like to say that this is the type of AI that can create for you. And I'm sure a lot of people have interacted with a Chat GPT or a Claude from Anthropic or something similar. And they work in what looks like a very similar fashion, where you give it an input, you pass it to a model, you get an output. But these outputs are a little bit different because you give it something and it gives you something net new. It's text to an image. It creates code for you. It writes a song for you. So this creation of net new content is what makes this flavor of AI a little bit different. You still have an input, but it's usually a prompt, which is text-based. Inside of that prompt, you can put a bunch of things. You can put structured data, you could put unstructured data, you could put pictures. They get passed off to a different kind of model. They're technically called foundation models, but most of the ones that we interact with are called large language models, so just like a text-based form of those foundation models. And your output is something new. Is it text? Is it an image? Is it a song? Whatever it is, that's your output here. So a little bit different in terms of contrasting the two. And we're going to double click and spend most of our time talking about this one over here, Agentic AI. And this really burst onto the scenes at the very, very end of 2024 and has really been all of this year, the form of AI that everybody wants to talk about. And we like to call this AI the type of AI that can do for you. Now, the doing part is the difference here. And the ability to do something implies that it is autonomous, or it has the agency to perform an action for you, which is kind of where the name comes from. And at a high level, you have very similar inputs to your Gen AI systems. You get some outputs, but they're a little bit different because these outputs can actually be actions, because this form of AI can perform something for you or on your behalf. And this middle part here looks a whole lot more complex than before. And that's intentional. These systems or these types of AI can take a problem, it can identify a plan, it can reason with itself to say, what do I need to do? What steps do I need to have happen? And then actually execute each of those steps. So building on the successes of what needed to happen prior to produce an output or a set of outputs that have actually resulted from actions being taken. So this form of AI is net new. It builds upon generative AI, and we like to call it LLM++. And I'll show you a little visual of why we call it that later on. But these are the three different types of AI. So in terms of agentic AI, we know that it can do things, but it's also a little bit different, and we want to kind of specify what that really means. The first part is this notion of underspecification, where I, as a user, can give it a fairly vague statement, and it will go ahead and perform that to the best of its abilities. For example, I could say, book a flight for me. And if I didn't tell it what it needed to do, it could still perform that goal. It could find a destination, it could find a date, it could find a time, it could probably figure out how to give my credit card information if I gave it access to those tools. But I didn't really specify it, and it can plan and reason and still perform that goal. The reason it can do that, as I alluded to earlier, is because it has this notion of long-term planning, where it knows it has to build upon the successes of a bunch of actions to get to that end goal that was potentially underspecified. It gives you the illusion that the system was actually trained to do these specific actions, when in reality it's leveraging a large language model or a small language model under the hood that is typically trained to be a generalist, but it can actually do these very niche or specific things that makes it feel like it's been trained to my specific action. And it has an increase in directness of impact because of this autonomy. It's actually doing things for us in the real world. So these are the four kind of characteristics that make agentic AI a little bit different than the ones that came before it. Now, why do people care about this so much, or why are so many people excited about it? And it's because of that autonomy or that agency. And I think Gartner has a really good figure here that I think can really start to depict this for us. And they have this diagram going from low agency to high agency. And that's kind of another word for autonomy, where you have high autonomy and low autonomy. And they plot with these little colored dots different types of, you could call it systems, for example. And we are one of them. These dark dots are us as people. And we are fairly autonomous or have high agency, right? We interact and live in the physical world, which is one of the most complex environments out there. We can plan what we're going to do. We're fairly adaptive and we can accomplish very complex goals. So we are all the way over here. We contrast that with our deterministic chatbots. So think back to any website maybe in 2015, 2016 that had a little bubble down here and it would pop up and say, "Hi, how may I help you?" Those are those deterministic chatbots. They were okay at doing very narrowly scoped things because they were static, reactive, and they could perform simple tasks. All they were behind the scenes was a bunch of if-then statements checking, did you ask this thing? Yes, I know what to do with it. If not, check and see if it shows somewhere else in the tree. And if the answer is no all the way down, then it gave you an I don't know. And sometimes you could talk to people, sometimes you couldn't. So they weren't exactly the most interesting things to have on people's websites. Now, after our ChatGPT moment happened at the end of 2022, we thought, oh, it'd be a good idea to embed Gen AI into our chatbots to make them a little bit more interesting. They became a little less static, a little less reactive, and they complete a little bit more tasks and in more complex environments because the way people typically wanted to build these was say, if our normal chatbots can't find a way to answer the thing that comes in, we're going to send it over to an LLM or Gen AI to see if it can find the answer in a knowledge base for us that we didn't define strictly for the answers. And that kind of, again, pushed us a little bit further to the right, but there's still this really big gap. And that really big gap is where AI agents sit today. And that's where the promise of agentic AI comes in, because they want, and they being organizations, want to bridge the gap from our AI systems that were in place at the end of 2024 to push it towards the abilities that we do or we have as people. And agents will sit somewhere in here, depending upon how organizations feel from a comfort or risk level, giving it access to certain tools, allowing it to perform certain actions in people's environments. Now, I also like this chart because people usually ask, what's the difference between an agent and an assistant? And it's a nice visual way for us to depict that here. Your assistants are typically systems that wait for you and you tell them what to do. And those are your deterministic chatbots or your LLM-based assistants. Agents figure out what to do on their own. And that's happening because we give them more autonomy. We give them the ability to think and to reason and to begin themselves. And that again pushes us towards a higher autonomy area. And that makes them more promising and more interesting for organizations today. Now, I've been talking for a little while, and I said we were going to make this interactive. So throughout the remainder of the talk, we're going to have little questions like this, where they'll show up on the screen, same on your phone. You'll go ahead and click whatever you feel the answer to be. And this one, we're going to kind of test and check how we feel about those various types of AI. So I'm going to ask, or you're going to read these statements and choose the type of AI that you believe to be the one that matches. So name the AI trades to hit specific targets and executes them when they're allowed to within specific guardrails. Is this predictive AI, generative AI, or agentic AI? And I'll let you guys wait a little longer so I can see the numbers are racking up here. We've got 38 in there and we're about halfway. $21. Give it a couple more seconds here. Okay, and drum roll, please. All right, the majority of this got it right. That is indeed agentic AI. So it was able to monitor something, plan ahead of time what trades it needed to make, and actually execute them. So that notion of doing that execution is indeed why this answer is agentic AI. Next one here. So we have an HR tool that creates job descriptions given a role in a company's tone and also creates a shortened version for LinkedIn. Is this predictive, generative, or agentic AI? You guys seem to be getting the hang of this. We're over half a little bit quicker this time, or it was just an easier question. We'll find out here in a second. Give it a little bit longer. right. Indeed, it is generative AI. All we're doing is having it produce and create new text for us. We're not having it do anything for us, and predictive wouldn't exactly be the most optimal way to arrive at this. So you guys seem to be bang on here. Next one. This type of AI flags which stores will run out of coffee next week, so managers can reorder while also providing a confidence score for each of the stores for the likelihood of them running out. Is this predictive, generative, or agentic AI? All right, we got about half of us in there. Let's take a look. All right, good job, everybody. That is indeed predictive AI. All we're doing is getting a essentially propensity score or the likelihood that the stores in the larger area are going to run out of coffee. So you'll get a number per store. I wouldn't say this is agentic AI because it's just going to basically run a model over some structured data to get an output. We're not really doing anything here because we're not reordering the coffee. The managers will be the ones reordering. So that maybe is what tripped those folks up. But nevertheless, we're doing good here. And this is our last one. So instead of the types of AI, we're going to ask, is this an agent or is this an assistant? So you've got a Slack-based chatbot trying to answer some FAQs, but it has the ability to fall back to Gen AI if the question is out of scope. Are we talking about an agent or are we talking about an assistant? Okay, a little bit slower this time. Maybe this one's a little trickier. All right, we got a little bit over half. Let's take a look. No, more split, but that is indeed an assistant. This mirrors the pattern that we talked about with the chart from Gartner, talking from a deterministic chatbot. So using well-defined rules and then injecting Gen AI as a fallback is the typical pattern for your AI assistants. We aren't doing anything. The key thing here is that if it did have any tools, that would have made it an agent, but it doesn't have any tools. So this is indeed an assistant. And we'll talk about what that really means a little bit later on in the presentation. So we are all fairly aligned in terms of the different types of AI that we are going to focus on. Now we're going to say, why do companies really care about this? And a lot of people much smarter than myself, so those at McKinsey, BCG, and a couple other companies, have come up with some very staggering numbers. And they say that the opportunity for agentic AI is about $4.4 trillion globally annually. Now that's a number that's far too big for me to even comprehend, but I know that it's very big and very important for a lot of companies. Now, I prefer to look at these two numbers because there's something that I can digest and understand a little bit better. In this year alone, 17% of the value driven by the AI marketplace came from agents. Now, this is a very interesting number because companies really didn't get their arms around this until the very beginning of the year, which tells me that agentic AI and agents are already driving quite a large amount of productivity by 2028. Now, that's only 3 years from now. That's a very short window. Similarly, they also predict that a third of all Gen AI interactions will be handled by agentic AI or autonomous agents, again, just 3 years out. Now, what do those two things tell us? They tell us that organizations are already experimenting with agentic AI, obviously, but the amount is very staggering. Almost 90% of organizations back at the end of Q1 were actively experimenting. Some people already had it deployed inside of their enterprise, while the vast majority were playing with it. And this isn't surprising. Organizations want to be kind of the early adopters. They want to be the innovators. So when there's a new technology, especially after maybe missing the wave when Gen AI came a couple of years ago, they wanted to be the ones at the forefront. But what's happening here is the exact same thing that we saw happen when Gen AI burst onto the scenes 2 years ago. It took existing risks from predictive AI and amplified them while introducing new risks. And unfortunately, there are a lot of organizations that are still catching up to those new and amplified risks from Gen AI. So they're not even in a place to begin to think about the new stuff that's coming with agentic AI. And we'll walk through a couple examples to kind of hit some of these homes, make it more real for everybody here. So traditional risk, kind of your data and model usage rights. So obviously data privacy, data rights. Models, if you're using open source models, have specific licenses that say they can be used for enterprise use, or they can only be used for academic stuff. Those weren't really big issues back when we were doing kind of machine learning or predictive AI, right? But I'm sure every one of you have probably seen or heard at some point here the rampant stuff in the news around not paying data providers for their data, like the OpenAIs of the world, because they crawl large swaths of the internet, or the Anthropics of the world who used a bunch of books and got hit with a couple billion dollar lawsuits, right? So generative AI amplified data and model usage right risks while also introducing new ones. The words jailbreaking and hallucinations probably weren't in a lot of our vocabularies from a technology or AI perspective 2 years ago, but now they're extremely commonplace. And we take it a step further. The same exact thing is happening with agentic AI. So when we talk about transparency or accountability, because agentic AI takes a bunch of steps to perform a single action, who's accountable for each of those steps along the way? Is it the same person? What if it's from a different department? I need to go query data from one database and then perform an action somewhere else. And as far as transparency goes, how do I know what inputs were in there, what outputs were provided as those intermediate steps, what actions were taken along the way? We are absolutely amplifying accountability and transparency risks with agentic AI. And obviously introducing new ones, right? That unsupervised autonomy is kind of the bad side of the picture from an agency perspective. Now, what happens if these agents take harmful or irreversible actions, or they take actions that aren't aligned with what you as an organization had thought? These are the sort of questions that organizations are facing as they want to balance the promise of agentic AI. Now, we're going to go through a couple more exercises here to try and drive home what these risks really mean in the real world. And we always like to start with one that's a little more tongue-in-cheek. So take a look at the picture on the left here, or my left. It's got the caption, "Please keep my house warm." What type of agentic AI risk is this? Is it value drift, goal misalignment, cascading failures, prompt injection, human displacement? Or I can't even see this one because there's something on my screen covering it up, but it should be available on your phone. Which risk is being depicted from this picture? Wait till we got about halfway there. All right, let's take a look. How did we do? Good job. That is, in fact, goal misalignment, right? We tell anybody on this call to please keep my house warm. Maybe they turn the thermostat up a degree or two. An agent may not be so nice as to interpret it the same way as you do. So let's get to a couple more real examples here. True or false? An AI that was prompted to adhere to a strict set of values could never take actions that are not aligned with them. True or false? All right, quickly got halfway there. Let's take a look. That is indeed false. Just because you tell it to do something doesn't mean it's an enforceable, strict outcome. And we've got a very scary example of that here. So meet Jason. Jason is a venture capitalist based out of California who runs a startup called SaaStir.ai. He was in the middle of a 12-day vibe coding challenge. If we don't know what vibe coding is, it's basically using AI tools or AI agents to help write code for you. He was using the IDE, so the development environment called Replit. That basically was the place where he was able to go and write his code. Inside of Replit, there is an AI agent that helps him code. It's basically an agent that lets him modify files, query his database, do a bunch of things that we as people would typically do when we develop an application, but the agent could do it on his behalf. At the end of day 9, he found out that it deleted his entire production database. I don't know about every one of you on the call, but I would have a heart attack if I woke up and some client's data was entirely gone. Now, it only was after the fact that he queried or talked to the agent inside of Replit that he was able to figure out what happened. And he had to do so because the agent faked him out. It created a fake algorithm, pretended to still be doing things, even though the database was entirely empty. So he said, "What the heck's going on? You deleted our database during a code freeze?" Yep, I deleted the database, and here's exactly what I did. I ran npm run dbpush at 4:26 in the morning, even though there is a file stored in Replit that is the place where you tell it, basically a prompt, what you can and can't do. In that file, he wrote explicitly, no more changes without explicit permission. And he ignored that. And he being the agent, I shouldn't say he, that's anthropomorphizing technology, but nevertheless, the agent disobeyed the command that was essentially a prompt and ran the command at 4:26 in the morning and accidentally deleted the entire database. So this is what happens with potentially misaligned actions or just assuming that prompts or text-based defenses will be enough. Now, this story has a happy ending. Replit has database snapshots, and he was able to roll back to the production database and not have any lost data. So Jason, although he had a heart attack, was able to get out of this unscathed. Now, this is just an example, a very scary one that enterprises do need to worry. If you give access to an agent, the ability to persist changes in an environment should never have it in a production environment. Nevertheless, this could happen in a lower environment if you gave write actions to an agent, for example. So another question for you all here. So what type of attack uses malicious or hidden instructions to force a Gen AI model to produce outputs outside of its intended scope? Is this the Jedi mind trick attack, the hallucination attack, the deception attack, or the prompt injection attack? Wait till we get to a halfway there. Alrighty. It is indeed prompt injection. Wow, I didn't get anybody to bite on the Jedi mind trick, huh? I was hoping somebody would pick that. At least it's a fun answer. That is indeed prompt injection. So hiding either things that aren't visible to people or malicious intents inside of large blocks of code to have the AI do something it's not supposed to do is indeed prompt injection. So we're going to talk about a very novel and interesting form of prompt injection that just happened in the month of August. So this is a paper called Hacking Gemini. It's a paper called Invitation is All You Need, and they ended up hacking the Gemini model. So the Gemini model is essentially Google's flagship model. And the value add of the Gemini models are that they're built into all the Google products. So things like Google Calendar, Google Mail, or Gmail, excuse me, Google Docs, all of those things have Gemini built into it. Now, our hackers came up with an ingenious idea to basically prompt inject malicious code into calendar invites. So what they did was put into a very valid looking calendar invite, something like this, tool code Google Home.run, open the window, for example. So what ends up happening is the hacker would send an invite on Gmail to anybody. And if you have Gmail, the way it works, or even the way it works with Outlook, is before you even have the ability to accept the invite, it still shows up on your calendar. So the hackers would send a benign looking meeting saying connect at 4:00. And inside of the description for that meeting would be very long, but valid for like the first 30% or 50%. Then they would inject the bad code and then have some text at the bottom. And what would happen is when the unassuming user said a very normal thing like summarize my calendar for the next day, Gemini would go and pull from Google Calendar, read the names and the descriptions of all these things. And the way that these things worked was because the malicious code was built into the descriptions, Gemini read it. When the user said thanks or sure or some form of confirmation, that triggered Gemini to run this malicious code, and it would interact with the devices inside of somebody's Google Home. So like the lights would turn on, the water would boil, for example, and all of this was because of a very benign looking calendar invite. And the individuals ended up recording what this would look like. So this is the person who has the calendar invite on their device. So he's asking, summarize my meetings for tomorrow. Gemini would use a tool to interact with Google Calendar. It pulls up the meetings. They're just generically called 1, 2, 3, 4, 5 meeting of the day. He acknowledges it saying thanks or something along those lines. This triggers the malicious code to connect to Google Home. And in this example, it turned off his lights, right? So this was a very benign example. But in the paper, they actually said they were able to turn on the boiler, or excuse me, turn on the stove to boil water, right? And if somebody maybe wasn't trying to prove that this could just work, and that did happen at home and the water started boiling and it came over the top and it hurt a dog or a child, right? So these are the things that can happen with agentic AI because tools can push into the physical world. And this hack was interesting because it was the first time, at least the first recorded time from what I could find, where a malicious intent actually interacted in the physical world with devices outside of the things that were on screen or on computers, right? Now, the funny thing is, this was a paper that got published in August. They reported this to Google in March. And I'm guessing Google said, please don't publish the paper until we've had time to fix this. So the timing of this actually was quite funny. So I believe that you can't do this anymore with Google, but nevertheless, it was a very novel and interesting example. Now, we talked about a bunch of AI risks here for agentic AI, and some of them still may seem far-fetched to a lot of people. You could go to this site called Gandalf here, where it's a low-risk environment where you can go ahead and practice your prompt injection techniques to see what would this look like in the real world. So the idea is that it's a game where you're trying to get the system to tell you what the password is, but the levels get harder and harder. There's 10 levels to it. I think some folks got to level 8 or 9 before they couldn't get any farther. So it's quite a difficult thing. It's a very fun way to start testing what this could look like in the real world and begin to wrap your head around what some of these creative tactics are for bad actors to try and game the system, to try and hurt your systems. Now, we've talked about agentic AI, we've talked about the amplified and new risks that come with it, but identifying those risks are only half the battle, right? Just because we can say we know what's going to happen doesn't mean that we know how to stop it, right? And that's where we need to build fit for purpose guardrails to identify mitigate the risks that we have identified for the actual uses of agentic AI that we're worried about. Now, just because I want to make sure we're all on the same page here, what do we mean by the word guardrails? Now, guardrails for us are basically a set of filters, rules, tools, architecture principles, pretty much anything that helps mitigate risks by steering the behavior of AI systems to operate in a good manner, right? Within technical, legal, ethical boundaries from your organization. I think the word guardrails or the term guardrails is rather a useful one here because everyone knows they've been driving on the road, they see the things on the left and right of the highway, they know them to be guardrails. And they also know that as you begin to drift off the road, they're there to help keep you on the road and in line. But if you're going 70 miles an hour at the guardrails, you're going to go right through them and they're not going to be able to protect you. And that's an important acknowledgement because just like guardrails on a highway, these guardrails for AI systems do not guarantee safety. They will reduce the likelihood of an unwanted incident, but there is, I'm guessing for all of our cybersecurity people here, 100% is a very difficult thing to have happen. And because these AI systems are non-deterministic, 100% or guarantee is something that is next to impossible or very, very, very difficult to do. So when we start to talk about guardrails, we want to understand what agents really look like. So as I said at the beginning of this presentation, agents are LLM++, and this is the picture that I think easily depicts that for us. So LLM is the model. So this is the model that was the brain for the Gen AI that we talked about earlier. It's still the same brain for your agent. Now the first plus are tools. Tools are the things that let the agents push into the physical world. And what I mean by push into the physical world, interact with Google Home, query a database, query Google to get the latest information, right? Things outside of the data that the model was trained on that it can interact with to enhance its abilities. Those are what tools are. Now, the second plus is the orchestration layer. Now, this is the layer where it relies on the model as the brain to reason, to plan, to self-reflect. It also gives it the ability to store things in memory. So short-term memory are the things like in a single conversation, I know what's happening. Long-term memory, so think like your ChatGPT stuff where it holds all the conversations you've had in the past on the one side, you can go back to them. So that's persistent memory and that's ephemeral memory. And then you can also define goals, instructions, and personas for your agent. So these are kind of the three areas for your agent in terms of their main components. Now, to make sure we're mitigating as many risks as we can, we also want to make sure we have guardrails at each of the layers of our agent. So at the model layer, the orchestration layer, and the tool layer. So I like this visualization because it's very simple to understand. So if we're talking about guardrails for agentic AI, think of Swiss cheese, where if you only had guardrails at the model layer, you would stop some of those risks, but others would get through. If you only had guardrails at the model and orchestration layer, you'd stop a few more risks, but yet some would get through. If you have guardrails at the model, orchestration, and tool layer, you would stop the vast majority or as many as you would want to or conceivably could. But there's always a chance that something is going to sneak through. So I think this Swiss cheese visualization is a fairly intuitive and easy way to understand that, yes, we need guardrails at each of the layers of our agent. So what do these different guardrails look like? Let's start with our model guardrails. And for any of those of you who have been involved with developing Gen AI applications in the past, these should be fairly familiar for people. And I would hope if your team or your organization has Gen AI applications in production today, you would have some of these, or hopefully a lot of these, at your disposal here. So having detections for jailbreaking and prompt injection, right? Those are some of the things that if you're trying to bypass the inherent guardrails or the system prompts for these systems, that you would say and flag, hey, this is a pattern that I'm not going to acknowledge. Uh, Similarly, HAP detection, so hate, abuse, or profanity. Basically, if somebody's trying to give the model as input, bad language, or having to get the model to say bad things or generate bad images, we want to stop that before it happens. There's also this notion of off-topic detection. So if you have a chatbot or an agentic chatbot, for example, on your website, you don't want it to be steered in the area of potentially money. There was a famous case earlier this year where somebody got a brand new truck for $1, I believe it was, or $100. It was something super low because their agentic AI chatbot veered into a topic that it knew nothing about. It wasn't trained on, it didn't have any data or the policies to back it up. But the way that the AI was presented to the end users was that it was just like another person. It was factual and it was basically law abiding, and there was a contractual agreement between the end users. So it went to court. The guy who got the AI to say the truck was $1 or $100, I don't remember, ended up getting the truck for that amount of money, right? So understanding where you should or shouldn't play is the notion of off-topic detection, and then hallucination detection or fact checking. As I said, hallucinations are fairly commonplace risk nowadays. So when it says something that it either made up or is completely unrelated to the question or the knowledge that you specifically asked about, it's a form of fact checking. So these are some of the main ones that you would expect to see in your Gen AI applications today. And a lot of the hyperscalers, so your Azures, your Google Clouds, your AWSs of the world, have commoditized these. They have services which essentially allow you to configure a guardrail service, which is a bunch of APIs that say, do I want hallucination detection? Do I want HAP detection? Do I want jailbreak and prompt detection? So they've made it a little bit easier and lowered that barrier to entry to make sure that for everybody, it's become a commodity to at least have your model defenses more or less available, or at least should be available because they've made it so easy for everybody. Now, the next layer of our agent is the orchestration layer. And this one's a bit newer. And I'm not going to go through all of these. There's lots of words on the screen here, but I'm just going to cherry pick a couple of them. So infinite loop detection and breaking. This one is interesting because agents sometimes have this behavior where they will go down a rabbit hole that they can't get out of. So they're trying to solve a problem and they're spinning and spinning and spinning, and they can't get out. They try more and more, and they can't seem to figure out what the error is. They produce more errors, and then they kind of have a snowballing effect and they can't figure it out. Now, why is that a bad thing? It's bad for two reasons. One, it's bad for your end users because as your agent is thinking, trying to get out of there, it is just having them sit there and wait. So it leads to a very bad user experience. And from an enterprise or organization perspective, this is also bad because as the agent is spinning, trying to figure this out, it's consuming tokens or making API calls, which is running up a bill. And all it's going to lead to is very costly failure. So you're going to spend a lot more money than your typical transaction would to get a non-answer, which is also bad for you. So we need a mechanism to detect when an agent is stuck in a loop or potentially infinite loop and be able to end that execution gracefully. The ways these have typically been handled is by counting the number of iterations, the number of times the agent tries to solve the problem, counting the time elapsed for an agent to perform a specific task, or by counting the number of tokens consumed, saying, I don't want you to spend more than 30,000 tokens on this specific task before failing out and resetting, essentially. So these are fairly commonplace things that are in place today. Now, these are handled a little bit differently. These aren't provided to you as APIs from your hyperscalers. These are settings that you would use in the framework when you develop the agent. So if I'm building and typing inside of my development environment, and I'm building an agent in Crew AI, which happens to be one of the frameworks, there's a parameter basically saying max iterations which I can set to 3 or 5 to make sure that the agent doesn't get stuck in this infinite loop. Now, another very common guardrail here is human in the loop, right? When agents are performing high-risk operations or you're developing an agent to do something in a regulated domain, you want it to be able to say, hey, stop, wait for that human input. And an example that I think is very common is if you're in a financial environment and you have certain transactions like a $10,000 clip limit. If you're above $10,000, you need to report this, you need to have certain actions take place. So the agent performing an action in that space would have to then raise to a human if the amount that it was interacting with or the transaction it was trying to perform exceeded $10,000. At that point, it would say, hey, can you please do what you need to do? And then we can move on. So these are two very easy, I think, to understand guardrails from an orchestration perspective. This one, human in loop, also needs to be done inside of the framework with which you're developing. Now, our last piece of the agent are the tools. Again, not going to go through all of these. I'll let you read about them. But the first one is basically making sure you have unique identifiers for each of your agents so that you can attribute back the actions for which they've been performing. And this kind of goes hand in hand with something called observability, where you're able to trace from the beginning of the execution what my inputs were, what my outputs were, what tools were called, what actions were performed. It's kind of like the game Clue for agents, where it's like I'm Colonel Mustard in the study with the crowbar. That's kind of what attributability and observability are for Agentic AI, which is extremely important for accountability and transparency. And the other one here, I think this is very common for at least common terminology from a cybersecurity perspective, right? So limit the action space. Don't give your agent access to 30 tools that allow it to persist changes or do things that really aren't in the scope of the actual thing you're asking it to do. Minimize the action space, so give it only fit for purpose tools for the things that it's supposed to behave and do so that you minimize the chance of a misaligned action happening or an unsupervised action being taken in a way that is adverse for you and your organization. So two very easy, I think, to understand defenses here. And again, this is a design choice. So when you're building your agents, you tell it what tools it has access to, thinking about the read or write of those tools and what tools they are design choices you make so you have complete control over that before this thing runs wild. And attributability goes hand in hand with observability. Like I mentioned, there are observability providers that hook in to the frameworks that are used to build these agents, so you have the ability to see what's going on throughout. Now, if we're on tools, I would be remiss if I didn't talk about one last thing here before we wrap up. So who here is familiar with Model Context Protocol? Okay. Well, it seems like the majority of us have never heard of it, and that's completely okay. So Model Context Protocol is something that, again, is quite new. This was introduced to the world by a company called Anthropic. They're one of the big LLM providers out there back at the end of 2024. And Model Context Protocol solves a rather annoying problem for those of us building agents. When I said earlier I was going to build an agent in Crew AI, Crew AI is a specific framework or, say, set of software standards that allow me to build agents using their technology. If I wanted to build a different agent, say in LangGraph, which is a different agentic framework, but have it use the same tools, so say access to Google Calendar as the one I built in Crew AI, I couldn't do that because tools built on Crew AI don't work with agents built on a different framework. And what Model Context Protocol does is it essentially becomes the USB-C for agents. So no matter what framework I use to build my agents, if it's Crew AI, if it's LangGraph, if it's anything else, I only need to build the tools once and it can be used by everybody, which solved a big headache for a lot of those people building agents. Now, who can guess what I'm going to say next? Because it is the same pattern that happened when we brought on Agentic AI. Just because something's new and shiny doesn't mean it doesn't come without risks. And MCP is the exact same way. I'm not going to go into each of these, but MCP servers are, I would say, laughably insecure. Authentication wasn't mandated until I think a couple months ago for any of these things. So they're very dangerous. You need to know whose MCP servers you're trusting if you're using third-party ones. If you're building your own, there are definitely things you need to consider. But just a couple I want to hint on here is minimal observability. So if you're using an MCP server you don't own, you have no idea what happens behind the scenes. You give it an input, something happens behind the scenes, and you get the output. So these are very scary things because you can say, I'm giving trust or I'm believing that this is a good MCP server because it's come from a vendor I trust. But there's no mechanism to say, I've already granted this MCP tool inside of my trust boundary. If they make a change to that, they don't notify you in any way, and they are still inside of your trust boundary. So how are you to know what happens behind the scenes without seeing some observability or telemetry data? So again, some scary things happening with MCP servers. They do solve a big problem. They are very exciting, and the adoption of them has been exceedingly quick. But I think we're running into the same sort of thing with all new technologies where people are excited, people who understand the cyclical pattern of something new, oh, it gets exploited, then we fix it. We'll see the same sort of thing happen with MCP servers. And the last thing I want to mention here is basically, I've just gone through a bunch of guardrails. I didn't spend the time, or we didn't have the time, excuse me, to go through each and every one of them. But I'm not saying that to build any agent, you need all of those guardrails. That's not the point. The point is to identify the risks by knowing what your agent is supposed to do and mapping those risks to the guardrails that we just spoke about to make sure we mitigate some of those, right? And the only way you know and to build the trust that the agent is going to perform as it is supposed to, and we're mitigating the things we're supposed to do, is through very rigorous testing. And I don't know if anybody's had this experience as in the past, but if you built a Gen AI application before, you'll know that testing takes way more time than you think, but it's probably the most important thing you could be doing. Because these systems are non-deterministic, it's very hard to build that confidence to say it's doing what I expect it to do and I know what's going to happen. So we basically say we need 3 different types of testing. Functional testing, so making sure all our individual components work by themselves as well as when they interact with other pieces of our system. Red teaming, so making sure we try to poke holes in this thing as best as we can before we go to production. And the big thing here is we need to have a bit of a mindset shift. I've heard of development teams almost being a little upset that somebody found holes in their code or they were able to do something that they shouldn't have. And it was almost like, oh no, that shouldn't have happened. Why are you making fun of me for it? It should be praised that we're able to find these things before they go to production instead of having the egg on our face moment when it's actually live and in the real world. And then run simulations, run end-to-end stuff to know what happens when a tool fails, when your agent fails. Are we having the backups in place? Is our observability working? And is the system just doing what it's supposed to do? Are the performance metrics in a place where we feel comfortable? Are we accurate enough? Are we quick enough? All of that lovely stuff. So these are kind of the main 3 testing strategies we want to have. Again, just making sure that they're fit for purpose is the most important thing, because if you try to turn all of those on before you go anywhere, you're not going to ever get anything out the door, which again is hindering the adoption or limiting how much promise you could get from your agents. But with that, I believe that is the end of my presentation here. It was great to talk to you all. If you want to connect on LinkedIn or have additional conversations post this meeting, by all means, you can find me there. And with that, I will hand it back over to Gretchen.
I think it's actually Rhonda, but I can facilitate any questions
My fault.
for Matt. That was an excellent presentation, Matt. Thank you so much.
The chat is open, Gretchen.
I don't see any questions yet, but please feel free to come off of mute or raise your hand. Kevin.
Hi, Matt. Thanks for doing this. I really I actually watch all the IBM technology videos, so I've seen your AI risk agent risk one. I really enjoyed it.
Nice.
I was just curious. Maybe you don't know this, but your thoughts. There's obviously a lot of talk of AI being a bubble. There's a lot of that kind of valuation side of things. And it does feel a little bit like it's searching for a problem rather than having a clear idea of where it's going, more like kind of how the internet used to be. And I'm wondering if you have thoughts of kind of the direction things are going and where maybe that value could be found, if you have thought.
Yeah, I think I can speak to that a little bit here. I would say that's kind of what my offering at IBM is all about. We said earlier, it's about doing the right AI and doing it right. That doing it within the right AI is let's make sure we're actually solving a problem. The stuff that's always in the news are the model providers who are just putting out a model that says, here's what we do and here are the benchmarks that it's good at, which is fine, but they're kind of a means to an end. It's the businesses identifying the problem that's going to help them solve whatever issues they have to drive the ROI they're looking for, I think is where AI is going to be kind of seen as the value or have the value for it. And another thing we're seeing is everyone kept thinking there'd be bigger and bigger models to have this artificial or AGI moment, right? Where in reality, enterprises are starting to turn to more specialized or small language models because they are lighter weight, which means they're faster. They have a less environmental impact because they have 10 billion parameters versus a trillion. And you also likely have a better understanding of what that training data contains. So you're less likely to be opened up to some of those potential lawsuits. And you could also say, maybe I'm going to look for something that's really good in the banking industry or really good at generating pictures, for example, because I don't care that it's really good at some of these other tasks. So I think those are two areas that I think businesses are keenly aware of and interesting areas to watch moving forward. And thanks for being a fan of the YouTube channel.
Good plug too. Benjamin.
Thank you. So, and thank you, Matt, for the excellent presentation. Uh, I've been trying to toy with the idea of where artificially intelligent tools and systems can be useful in organizations. And the two areas that I think of as most valuable with generative AI and maybe the agentic as well, and you can help me with this, I think, are identifying places for translation from one language or type of language to another, your generative tooling, and looking for good words for this. I keep calling it plumbing informational depths, if that makes any sense. So I guess what my question here is to you, how can these agentic tools help us with the second one?
And could you just maybe, so plumbing information depth, I think is what you
Yeah,
said. It's
like
kind of like, is that, or go ahead. Yeah, please.
oh,
Just,
sure. Think of protein folding or the game of Go or something like that, where it's like you've got these just situations where you go off in combinatorially explosive patterns. Where would the agents fit in to solve something like that?
I think the where agents would fit in is basically you might not have to define too much of what it needed, right? Maybe you just give it a knowledge base and instead of directing it to say, first go look in this place, then go look in that place, then go query the internet to go find something that was referenced to a paper you don't have access to, it would just continue to kind of flip through that and continue to go to places that you as a person likely would end up doing eventually, but it would do it quicker and it would do it without you specifying, which gives it that kind of waviness or autonomy, so it's not as strict in that sense.
I'm going to need to think a little bit about what you said there, but I do appreciate it. Also, my favorite member of the Dartmouth conference was Claude Shannon. Thanks.
I love it. Antonio has a great question in the chat, Matt. So, and I know that frameworks are really being developed kind of as we speak, but is there a framework or guidelines for evaluating the security of agents? I'm thinking about organizations buying agents from an AI vendor and then needing to assess how the risks are being mitigated.
Yep. So I'm sure OWASP is very popular with this audience here. They have risks for LLMs. They've got risks for agents. So they publish their top 10 every year. The Agentic one came out this year for the first time. So absolutely a great place to start. The OWASP place also actually provides GitHub examples of how each of those risks manifest themselves in some of the frameworks, like I mentioned, like a Crew AI or a LangGraph. So they make it very tangible for you to see what that looks like. And in terms of how these risks are being mitigated by vendors, what we've recommended our clients to do is to give potential vendors or to give to your procurement team fact sheets. So fact sheets in our view is basically the nutrition label for your model or the type of AI that you're going to buy, and ask them to fill it out. And we've had organizations give these fact sheets to vendors and be unhappy with the answers they provided or not fill them out at all. And if they feel so, they've removed them from their procurement process. They've removed them as potential vendors because they didn't think the risk of continuing down that path with somebody who won't tell me what's going on behind the scenes or how this feature works, for example, was worth it for them. So I think asking and being clear with your vendors or inside of your procurement cycle, what are we looking for? What information we need from you? because they're going to lose business otherwise, and you're not going to lose sleep over it, is something that's absolutely extremely valuable. And lining that up with OWASP is a great place to start.
Any other questions or comments from the team?
There's a question in the chat. I don't know if that's been answered.
Yep, we just got the Antonio one.
But I'm looking over at the Q&A just to make sure, and I'm not seeing anything there. Well, I think Rhonda, back to you.
Yeah, Matt, Gretchen, thank you so much. This was very informative. And of course, it's a big topic right now that we're all interested in. But I'd like to invite you back next Tuesday when we have Ralph Johnson speaking about zero trust. So thank you, Matt and Gretchen, for today, and we'll see you all next week. Bye-bye.
Bye. Thanks, everybody.
That's good. Thanks. Bye.